Now we start off with the chapter of differentiation. Now let's learn of what is differentiation and how do we do differentiation. So what is differentiation? Now differentiation is a process is the process of converting an equation with respect to x to the power of n in the form nx n minus 1. So this form we converted into this form. The differentiation is denoted by dy over dx. Now, why do we do differentiation? That is a question that is going to be resolved in the further videos. But for now, it is just necessary to understand what is differentiation and how do we do differentiation. Why do we do differentiation? That is a question that is a concern, answer to which is going to become apparent in the later videos. So, for example, we have a question y is equals to x to the power of n, where n is the power of x. Y equals to x to the power of n, dy over dx is equals to nx n minus 1. This equation of y being differentiated and converting it to dy equals to dx form. Now let's try an example. For example, we have the equation in y is equals to x cubed. Now after that being differentiated, dy over dx becomes, this power becomes the coefficient of x, and then the power gets subtracted by 1. And this is simplified to 3x squared. So y equals to x cubed is being differentiated to 3x squared. Okay, now let's try some of the more complex examples of differentiation. Let's first try this, differentiating this equation, x cubed minus x squared plus 5x minus 6. Now let's attach a power of x to all of them. This is obviously x cubed, this is x squared. 5x, let's write this as 5x to the power of 1. This has no x, so we can write this as x to the power of 0, because x to the power of 0 is going to be a 1, and then 1 times the 6 is just a 6. So let's just try to call a constant as 6x to the power of 0. Let's call this equation in terms of y, x cubed minus x squared plus 5x1 minus 6x to the power of 0, and then dy over dx is going to be 3x, 3 minus 1, minus 2x, 2 minus 1, plus 5 gone on the 5 put aside for now, and then 1x, 1 minus 1, then minus 6 times 0x, 0 minus 1. This becomes 3x squared, this becomes minus 2x, this becomes plus 5x to the power of 0, and 6 times 0, anything multiplied by 0 obviously gives you a 0. This becomes a 3x squared minus 2x, 5 times x to the power 0 means 5 times 1, you don't have to write negative 0, 3x squared minus 2x plus 5. So the equation in y is being differentiated into dy over dx, where 3x squared minus 2x plus 5. Let's try another complex example of differentiation that involves fractions. Let's write that equation. We have 4 upon x cubed plus x cubed over 4. Now we can write 4 upon x cubed as 4x to the power of minus 3, because when we bring x cubed up, when we reciprocate this, we know that whenever we reciprocate a term, its power changes its sign. If we are reciprocating this term, its power is going to change its sign. We don't have to do anything for this one. We can just write this as 1 upon 4 and then x cubed in the bracket. And then let's call this a term in y, 4x minus 3 plus 1 upon 4 x cubed. And then we do dy over dx is equals to 4 times minus 3x minus 3 minus 1 plus 1 upon 4 times 3x3 minus 1. This becomes minus 12x to the power of minus 4. This becomes plus 3 upon 4x cubed. We can reciprocate this to make it into a positive, so minus 12 upon x to the power of 4 plus 3x cubed upon 4. This is dy over dx. This is the when this is differentiated, you get this. This is how we end up with differentiating this complex example.